Lesson 29. Machine Learning and Strategy Optimization. Expanded. Let me start with the honest version, because anyone selling you machine learning for trading without the caveats is lying to you. Machine learning in trading is not a crystal ball. It does not predict where the price is going. If you come into this expecting to train a model that whispers Bitcoin at 65,000 tomorrow into your ear, you are going to be disappointed, and probably poorer. What machine learning actually does is something quieter and more useful. It looks at a lot of noisy data and tells you something like, based on the last 1,000 times conditions looked roughly like this, there is a 62% chance the price edges up over the next hour. That is a probability, not a prediction. And the difference matters, because it changes how you use the output. Here is the first big myth I want to kill. People hear machine learning and they picture deep neural networks doing magic. The truth is, in trading, the simple models usually win. A random forest, a gradient boosting model, those tend to hold up better out of sample than some giant deep learning architecture, partly because they are harder to overfit. Partly because you can actually understand what they are doing. If you cannot explain to yourself why your model is making a decision, you should not be trusting it with money. The second myth is that you need a supercomputer and terabytes of data. You do not. 6 months to a year of clean hourly data on a single laptop is enough to build something real. What you need is not more data. It is better features, and that is what most of the work actually is. What machine learning can realistically do. Let me be specific, because vague promises do not help anyone. It can combine a lot of indicators into one signal. A human trader can watch maybe 5 or 6 things at once before it gets noisy. A model can weigh 100 features simultaneously and give you a single number. It can adapt. Indicator parameters that worked in 2021 might be useless in 2024. A retrained model can shift with the market. It can flag risk. Instead of just predicting up or down, it can estimate the probability of a drawdown, or detect when the market regime has shifted, or tell you that volatility is about to expand. And it can help with execution, like timing entries inside a range, or estimating slippage from order book depth. Look at the funds that actually do this well. Renaissance Technologies 2 Sigma. They post returns that sound almost embarrassing to repeat out loud. But here is the part people miss. Their edge is not the model. It is the entire system around the model. The data pipeline, the risk framework, the understanding of market microstructure. The model is one piece. If you walk away with one thing from this lesson, let it be that. Success comes from systems, not models, and risk management matters more than prediction accuracy. The pipeline. In plain language, when you build an ML strategy, you do roughly 4 things. You build features, you define a label, you train a model, and you validate it. Let me walk through each. Features are the inputs, the price, volume, and any derived signal you think carries information. The mistake people make here is throwing every indicator they can find at the model and hoping it sorts them out. That works less often than you would think. What works better is building features that capture something real about how markets behave. So you compute returns at different horizons, 1 period, 3, 5, 20. You compute volatility, both the short and the long version, and the ratio between them. Because that ratio tells you whether the market is calming down or heating up. You look at where the price sits inside its recent range, the position between the recent high and low. You look at the spread between high and low as a rough proxy for intraday movement. Then technical features, the usual suspects, moving averages, RI at a few periods, Massachusetts, CD, stochastics, Bollinger Bands. But the part that actually helps is not the raw indicator, it is the relationship. Price relative to a moving average. RSI change over the last few candles. Whether MACD is above or below its signal line. Those relationships are usually more informative than the levels themselves. Volume is its own world. You want volume ratios. On balance volume, money flow index, VWAP. The gap between price and VWAP. Volume tells you whether moves have conviction behind them, and that matters a lot when you are trying to separate signal from noise. Then there are the less obvious ones. Candlestick patterns, doji, hammer, engulfing. ADX for trend strength. A rune for direction. And time features, which people forget, hour of day, day of week, encoded cyclically using sine and cosine, so the model understands that 23 o'clock and 0 o'clock are actually close together. Without that cyclic encoding, the model will think midnight and late evening are unrelated. The label is what you are predicting. You have two main choices. Classification, where you say the next move is up, flat, or down, usually with some threshold so you ignore small moves. Or regression, where you predict the actual return magnitude. Classification tends to be more forgiving for beginners, because the model only has to get the direction and rough magnitude right, not the exact number. For the label horizon, think about your trading style. If you trade on hourly candles and hold for half a day, predicting 5 candles ahead is reasonable. If you predict too far out, you are basically forecasting noise. Number training and validating the honest way here is where most beginners quietly sabotage themselves. They take their full dataset, they split it randomly into train and test, they train a model, they see 85% accuracy, and they think they are done. They are not. They have built something that has seen the future. Time series data has to be split by time. The first 70% chronologically is your training set. The last 30% is your test set. No shuffling, no random folds. Because if you shuffle, you leak future information into the training, and your backtest lies to you. Even a single train and test split is not enough. You want walk-forward analysis. The idea is to simulate how the model would actually perform in production. You train on a window, you predict the next chunk, you record how it did, you slide the window forward, you repeat. 5 or 6 passes minimum. If your model is robust, performance should be roughly stable across the windows. If it falls apart in some windows and shines in others, you have a problem. The way I think about it is this. A backtest on one period tells you whether your model happened to fit that period. A walk-forward analysis tells you whether your model generalizes. Those are very different questions. Number hooking it into a Freqtrade strategy once you have a trained model. Integrating it into a Freqtrade strategy is the easier part. You save the model and the scaler, the thing that normalizes your features, and you load them in your strategy's init method. Then in your indicator function, you recompute the same features you used in training, scale them, and ask the model for a prediction. The key decision is how you use the output. The wrong way is to blindly buy whenever the model says up. The right way is to use the model as one input alongside your traditional signals. So you might say, buy when the model predicts up with at least 65% confidence, and RSI is oversold, and MAAC just crossed above its signal line. You are stacking conditions. Each one is imperfect, but together they filter out a lot of bad trades. You should also build in a fallback. If the model fails to load or the prediction throws an error, you do not want the whole strategy to die. You want to fall back to the traditional signals and keep trading. Resilience matters more than peak performance. The other place ML helps is exits. A model can tell you when the odds have shifted, even before your traditional exit signals fire. And you can use it for custom stop losses. Tightening the stop when the model predicts a drop, widening it when the model is confident in the upside. Number Freqi. The proper way there is a cleaner path, and it is called Freqi. It is Freqtrade's built-in machine learning module, and honestly, if you are going to do this seriously, you should use it rather than rolling your own. Why? Because Freqi handles the parts that are easy to get wrong. It manages the training window, the rolling retraining, the data splitting, the feature expansion across timeframes and correlated pairs. You configure it once in a JSON file, and the framework does the heavy lifting. You install it as an extra, basically adding the Freqi option to your Freqtrade install, plus your choice of model libraries, like GBM, CatBoost, XGBoost. Those three are what most people use for tabular financial data. Like GBM is fast and surprisingly strong. CatBoost handles categorical features gracefully and is robust with limited tuning. XGBoost is the old reliable. In your strategy, you implement a few specific methods. One that defines the features. One that defines the targets, which in Freqi convention are columns prefixed with an ampersand, like a return target or a direction target, and the framework trains and predicts automatically. The configuration has a few parameters that matter a lot. The training period in days, how much history you train on. The backtest period in days, how far forward you test before retraining. The live retrain interval in hours, how often you retrain in production. A common setup is 45 days of training, 15 days of backtest, Retrain every 4 hours live. You tune these to your time frame and to how fast you think the market regime shifts. You can also include multiple timeframes as features, so the model sees the 5-minute, 15-minute, and 1-hour picture at once. And you can include correlated pairs, so when you are trading Bitcoin, the model also knows what Ethereum and Solana are doing. Number overfitting and the red flags. Let me come back to overfitting, because it is the disease that kills machine learning strategies, and it has 100 forms. The obvious red flags are easy. If your backtest shows 1,000% return, you are fooling yourself. If your Sharpe ratio is above 5, you are fooling yourself. If your win rate is over 90%, you are fooling yourself. If your maximum drawdown is less than 1%, you are fooling yourself. Real trading does not look like that. Real good strategies are more like 15 to 30% annual return with a Sharpe around 1 to 2, with real drawdowns along the way. The subtler red flags are where it gets dangerous. Owen is the gap between training and test accuracy. If your model gets 95% on the training set and 58% on the test set, it has memorized the training data. It has not learned anything generalizable. A healthy gap is small. Another is instability across walk-forward windows. If accuracy swings from 70% in one window to 45% in the next, your model is fragile. Robust models are consistent. Fragile models look great on average and lose money in specific periods. Then there is feature importance. If one single feature dominates the model, you have probably found a leak. If the model is essentially just a transformed version of the target, congratulations, you have trained a model to predict itself. If something called future return or target shows up with high importance, you have a data leak. Go back and fix your pipeline before you trust any backtest number. Data leakage deserves its own moment, because it is the sneakiest. The classic mistake is using a negative shift in your code, which reaches into the future, or computing a moving average with centering turned on, which includes future candles in the calculation, or accidentally including the high or low of the current candle in a feature that is supposed to be predictive at the open. All of these produce backtests that look amazing and live results that bleed money. The rule is simple. Every feature at time t must be computable using only data from time t-1 and earlier. If you cannot say, with certainty, that you could have computed this feature in real time at that moment, you have a leak. There is also survivorship bias, which is when you backtest only on coins that still exist. The ones that went to zero, got delisted, or had their project collapse, are not in your dataset. So your historical returns look better than what you would have actually experienced. If you are testing on a coin that has 5 years of clean continuous data and never had a major drawdown, ask yourself why that coin is still around. Number risk management, even for ML the last piece, and honestly the one that decides whether you survive long enough for the model to pay off, is risk management. Position sizing should respond to model confidence. If the model is barely above your threshold, take a smaller position. If it is highly confident, you can size up within limits. Always cap risk per trade. 2% is a common ceiling, and cap total portfolio exposure. 10% is a reasonable ceiling. Skip trades when conditions are bad. If market volatility is spiked, if the model has been underperforming its baseline recently, if confidence is below your floor, sit on your hands. The model does not have to trade every signal. Stops should be dynamic, tighter when the model expects a drop or when volatility is low. Wider when the model is confident in a big move and volatility justifies the room. And in live trading, you monitor calibration constantly. Compare what the model predicted to what actually happened. If directional accuracy drops below 52%, which is barely better than random, your model has degraded and needs retraining. If the predicted magnitudes stop correlating with actual magnitudes, your model has lost calibration. Build the monitoring before you need it, not after. Number what to realistically expect. Let me end where I started. With honesty. A realistic good strategy returns 15 to 30% a year. A great one, with higher risk, maybe 30 to 50. Anything claiming more than 100% in a backtest is almost certainly overfit. Real ML trading is a slow grind of feature engineering, careful validation, incremental improvements, and constant monitoring. It is not glamorous. Start simple. A random forest with 10 well-chosen features will outperform a giant neural network with poorly chosen ones every time. Use 6 months to 2 years of data. Validate everything with walk-forward analysis, not just a single train and test split. Dry run before you go live. Small capital before large capital. And remember, the goal is not a perfect strategy. It is a robust one that holds up across market regimes, that you actually understand, that you trust enough to let run when you are losing, and have the discipline to pull when something has genuinely broken. The model is a tool. The system around it is what makes money.